endangered wild horses are returning to the steppes of Kazakhstan for the first time in 200 years. It's part of an ambitious scheme to return them to their original habitats.
When the last wild Przewalski's horse vanished from the Central Asian steppe in the late 1960s, most experts believed the species had reached the end of its road. Extinct in the wild and clinging to survival in a few distant zoos, these rugged, thick-necked horses seemed destined to live out their days behind fences. But then, decades later, they released a herd of these near-extinct horses into China's desert.
We managed to get those horses here alive and healthy all the way to this reintroduction center.
What happened next shocked biologists from all over the world. This is a story of survival against all odds. Let's start from the very beginning. Path to extinction. The Przewalski's horse, or Equus ferus Przewalski.
These Przewalski's horses are the first of their kind to gallop the vast steppes of Kazakhstan in nearly 2 centuries.
Has long held a unique status in the animal kingdom as the last truly wild horse species on Earth. Unlike feral horses such as the Mustang, which descended from domesticated ancestors, the Przewalski's horse has never been domesticated. Its native range historically extended across the steppes of Central Asia, especially in modern-day Mongolia and parts of northern China.
Taki, as they're known here in Mongolia, were formerly widespread across Central Asia in steppe habitat.
These horses are genetically and physically distinct from domestic horses. They have a stocky build, a thick neck, shorter legs, a large head, a stiff upright mane, and notably lack the forelock that domestic breeds have. This physical robustness was well suited to the harsh, arid conditions of the Central Asian plains, where seasonal extremes and minimal vegetation defined survival. The horse was first brought to scientific attention by Russian geographer and explorer Nikolai Mikhailovich Przewalski during an expedition to Mongolia in the late 1870s. Although the local people, including Mongolian nomads, were well acquainted with these animals, it was Przewalski who collected the first physical specimen that led to the species' formal scientific description. In 1881, the species was named in his honor. This scientific recognition began to draw global interest to the animal, even as its numbers in the wild began to dwindle. The decline of Przewalski's horse was precipitated by a confluence of anthropogenic and natural factors. Human expansion into Central Asia in the early 20th century brought about increasing competition between wildlife and domesticated livestock, particularly sheep, goats, and camels. This led to overgrazing of the natural grasslands, thereby reducing the food available to wild species. Przewalski's horses, already slow to reproduce and requiring vast ranges for grazing, struggled to compete. Overhunting, sometimes for meat, more often for sport or capture, also played a significant role. The horses were pursued relentlessly by trophy hunters and specimen collectors from Europe and Russia, further diminishing their already shrinking population. Additionally, the introduction of firearms, motorized transport, and more sophisticated hunting techniques in the early 1900s allowed humans to access and exploit even the most remote habitats. The cumulative stress of hunting pressure and habitat loss was exacerbated by extreme winters, locally known as dzuds, which periodically devastate steppe ecosystems. During these events, heavy snow, freezing temperatures, and icy conditions prevent animals from accessing grass, leading to mass starvation. Przewalski's horses, with no food reserves and little human intervention at the time, were especially vulnerable. Each severe winter drastically reduced wild populations and, as sightings became rarer, it became clear the species was on the brink. The last confirmed sighting of a wild Przewalski's horse was in 1969 in the Dzungarian Gobi region of southwestern Mongolia. After that, the species was declared extinct in the wild by the International Union for Conservation of Nature. What remained were only a handful of individuals, just 12 to 14 viable horses, scattered across European zoos and private collections.
We managed to get those horses here alive and healthy all the way to this reintroduction center.
These were descendants of approximately 13 wild-caught horses, mostly taken from Mongolia between 1899 and 1902, plus a few foals born to captured mares. But the story does not end here. No, in fact, this was just the beginning. International captive breeding programs. The foundation of modern Przewalski's horse herds lies in the work of a few dedicated institutions, breeders and conservationists. Key individuals such as Dr. Ernard Mohr of Germany and Dr. Christian Schroeder of the Munich Zoo were instrumental in the early decades of the 20th century in tracing the pedigrees of captive individuals and identifying the remaining genetically pure horses, those not hybridized with domestic horses, which had occurred in some facilities. In 1959, a pivotal moment came with the creation of a formal stud book, managed centrally in Europe, which documented the lineage of every known Przewalski's horse. This stud book would become the backbone of the global breeding strategy. By the 1970s and early 80s, the breeding population, though still critically low, was distributed across several institutions, including the Prague Zoo in the Czech Republic, Hellebrunn Zoo in Germany, the Askania Nova Biosphere Reserve in Ukraine, and the San Diego Zoo in the USA. The Prague Zoo, in particular, would emerge as one of the leading stewards of the species, maintaining one of the largest and most genetically diverse herds. In North America, the Bronx Zoo and the Minnesota Zoo were also active participants in breeding efforts. These institutions formed the core of an emerging international network coordinated under the European Endangered Species Programme, or EEP, and its counterpart in North America, the Species Survival Plan, or SSP, managed by the Association of Zoos and Aquariums, or AZA. Under these frameworks, breeding recommendations were issued based on genetic assessments to maximize heterozygosity and minimize inbreeding depression. Genetic material, both live animals and semen, was exchanged between facilities to preserve diversity across continents. One of the most notable scientific contributions during this period was the use of artificial insemination and later embryo transfer to enable the reproduction of genetically valuable individuals without physical relocation. This was especially important for aging stallions or for pairing individuals that were not behaviorally compatible. As early as the 1980s, scientists began using cryopreservation to store semen from genetically rare stallions. These techniques allowed conservationists to manage reproduction across distance and time, bypassing logistical and behavioral constraints that would otherwise limit pairings. Throughout the 1980s and 1990s, these combined efforts began to show results. The captive population grew steadily.
And the only true wild horse subspecies. Its lineage split thousands of years ago.
In 1985, the global number of Przewalski's horses was still under 400. By 1990, that number had risen to over 750 individuals. By 2000, the number exceeded 1,200, with genetically managed populations spread across Europe, North America, Australia, Russia, China, and Mongolia. More than 95% of these horses could trace their lineage back to 13 wild founders, with an even smaller number, around 7 to 8 individuals, contributing the bulk of the genetic material. This meant that the species was still genetically bottlenecked, but careful pairing and controlled breeding kept the inbreeding coefficient from rising too quickly. During this time, specialized breeding centers were developed with the sole aim of preparing horses for eventual reintroduction. One such center was the Les Villarets Reserve in southern France, managed by the Association TAC. Founded in 1990, the reserve housed horses in semi-wild conditions, simulating the environment of the Asian steppe to help animals regain natural behaviors. Another was the Wilds in Ohio, USA, a large conservation center that bred Przewalski's horses under minimal human interference. The movement toward reintroduction began to take form in the late 1980s, spurred by increasing captive numbers and improved genetic data. In 1992, the first successful reintroduction took place in Hustai Nuru National Park in Mongolia. Horses from European zoos were flown in and acclimatized to local conditions before release. These early reintroductions included 15 to 16 individuals per cohort, with multiple waves continuing over the next decade. All individuals were genetically screened prior to release to ensure maximal diversity. By the end of the 1990s, captive populations were robust enough to support multiple rewilding programs, including in Mongolia, Kazakhstan, and China. Captive breeding had evolved from emergency genetic triage into a globally coordinated conservation success story, built on decades of meticulous record-keeping, data sharing, and cross-border cooperation. But the work was far from done. Reintroduction. Efforts globally. Once the captive population stabilized and genetic management protocols were established, conservationists shifted their focus toward returning the horses to their original habitat. Mongolia, home to the horse's historical range, became the epicenter of these reintroduction efforts in the early 1990s. Mongolia's involvement was both geographical and cultural. The horse, known locally as taki, holds deep national significance.
The Przewalski's horse is genetically different and the only true wild horse subspecies.
With government backing and international support, the first formal reintroduction began in 1992 at Hustai Nuru, a protected area approximately 100 kilometers west of Ulaanbaatar. The project was led by the Foundation for the Preservation and Protection of the Przewalski horse, in collaboration with the Mongolian government and Dutch NGO Stichting Reserves Natuurbeheer. Hustai Nuru was declared a national park in 1993, encompassing roughly 50,000 hectares of steppe and forest-steppe terrain suitable for the horses. The reintroduction methodology followed a three-phase structure. First, small groups of captive-bred horses were selected from genetically verified lineages managed under the International Stud Book. Second, they were transported to acclimatization enclosures in Mongolia, where they spent several months adapting to the climate and diet. Finally, once they demonstrated health and behavioral readiness, they were released into the park. The first batch in Hustai included 15 horses, stallions, and mares flown in from the Netherlands. Over the next several years, multiple additional groups followed from zoos and breeding centers in Germany, Switzerland, and France. Hustai's population grew steadily. By 2005, the number of wild Przewalski's horses in Hustai exceeded 150, distributed across several family bands and bachelor groups. Monitoring data showed that the horses not only survived, but bred successfully, with foals born annually and survival rates improving year over year. Horses adapted to native forage, harsh winters, and predators such as wolves, though some losses did occur during dzud winters. Importantly, minimal human interference was maintained after release, apart from periodic population checks and veterinary support in emergencies. Simultaneously, a second major reintroduction site was established in the Great Gobi Bee Strictly Protected Area, or GGB SPA, in southwestern Mongolia. Unlike the forest steppe of Hustai, GGB SPA is a true desert steppe ecosystem located near the Dzungarian Basin, closer to the horse's last known wild habitat prior to extinction. This effort began in 1992, with the first horses arriving in 1997 through a joint project involving the International Tahi Group, or ITG, the Mongolian Academy of Sciences, and the government of Bavaria, Germany. The reserve covers over 9,000 square kilometers, offering enough space for large herds with minimal conflict with pastoral communities. GGB SPA presented different challenges compared to Hustai. It is more remote, with sparse vegetation and extreme climatic variability. Horses had to adapt to finding water over long distances and managing low-quality forage. However, by 2010, the population in Gobi B reached nearly 100 individuals, with natural births contributing to its growth. By 2020, that figure rose to more than 200, though fluctuations have occurred due to harsh winters and natural predation. Meanwhile, in Europe, the Association TAC in France established the Le Villaret Reserve in 1990 in the Cévennes National Park. Here, horses lived under minimal human control in semi-wild conditions, serving as a behavioral and ecological bridge to full reintroduction. In 2004 and again in 2011, horses from Le Villaret were transported to Mongolia to supplement the gene pool at Gobi B. These translocations helped expand genetic diversity and mitigate founder effects. The ultimate success metric of reintroduction lies in natural reproduction and the emergence of multi-generational wild-born individuals. In Hustai, the third generation of wild-born horses was observed by the late 2000s. Foaling rates remained consistent, averaging between 20 and 30 births annually, with a survival rate of over 70% in moderate climate years. Social structures resembling those of historical wild herds emerged, including harem bands led by dominant stallions, as well as non-breeding bachelor groups. The IUCN reclassified Przewalski's horse from extinct in the wild to endangered in 2008, based on the successful establishment of multiple self-sustaining wild populations, Hustai, Gobi B, and Komin Tal, a newer site in western Mongolia developed in the mid-2000s. Globally, the total number of Przewalski's horses, including captive and wild individuals, exceeds 2,000. All are traceable to the original 13 to 14 founders, but China took a step even further. China's role in conservation. Following the species' extinction in the wild by 1969 and the subsequent start of reintroduction efforts in Mongolia and Europe, China launched its own efforts in the late 1980s and early 1990s. These efforts were grounded in long-term planning, cross-institutional collaboration, and the establishment of multiple breeding and research facilities aimed at securing a sustainable population of genetically viable horses adapted to native Chinese ecosystems. The earliest and most influential institution in China's conservation of the Przewalski's horse is the Xinjiang Wild Horse Breeding Center, established in 1985 near the town of Jimsa, located northeast of the Dzungarian Basin and close to the eastern edge of the Gobi Desert. The site was strategically chosen for its ecological similarity to the horse's original habitat, semi-arid, cold desert grasslands, and its proximity to potential future reintroduction zones. The breeding center began with a foundational group of horses imported from overseas. Between 1986 and 2005, China received 24 Przewalski's horses from various countries, including the United Kingdom, Germany, and the United States, notably from the San Diego Zoo, the Munich Zoo, and the Askania Nova Biosphere Reserve in Ukraine. By 1993, the Xinjiang Center had produced its first captive-born foals. The staff at Jimsa focused on replicating natural conditions, including forage types and exposure to temperature extremes, with the goal of preparing animals for eventual reintroduction. Over the next 2 decades, the breeding program showed steady success. In 2018, the Xinjiang Wild Horse Breeding Center bred over 400 Przewalski's horses, with the facility maintaining a stable population of approximately 150 to 180 animals at any given time. A second cornerstone of China's Przewalski's horse program is the Wuwei Endangered Animal Breeding Center, located in Gansu Province, on the edge of the Tibetan Plateau. Founded in the early 1990s, this center functions as a satellite facility that collaborates with Xinjiang and other wildlife institutions to increase breeding capacity and house overflow animals. It is also a genetic safeguard and a potential location for future rewilding trials. The Wuwei Center has contributed dozens of foals to national conservation objectives, including for experimental field releases and scientific study. The Beijing Wildlife Park also played a vital role during the formative years of China's conservation efforts. While not focused solely on Przewalski's horse, the park provided animals to broaden the genetic base and participated in exchanges with other Chinese institutions. These urban-based centers played a crucial role in public education and policy advocacy, helping raise awareness within China's scientific and governmental circles about the importance of protecting the species. China's reintroduction initiative took a major leap forward in 2001 when the first batch of captive-bred Przewalski's horses was released into the wild in the Kalamaili Nature Reserve, an expansive area of 14,000 square kilometers in the eastern Jungar Basin in Xinjiang. The site was chosen after extensive ecological assessments confirmed it could support free-ranging horse populations. The initial release included 27 horses, carefully selected and acclimatized in pre-release enclosures. The project was coordinated by the State Forestry Administration of China, with technical support from Xinjiang's breeding center and oversight by national ecological monitoring bodies. Over the following years, China followed a phased approach to reintroduction, China's rewilding strategy. The success of the captive breeding phase allowed Chinese authorities to initiate the second phase of their plan, ecological adaptation through semi-wild enclosures. At the Kalamaili Nature Reserve, a series of fenced acclimatization zones were constructed, mimicking the natural steppe ecosystem while offering limited protection from predation and starvation. Horses were selected based on health, age, and behavioral readiness. These zones allowed animals to experience foraging on native vegetation, interaction in natural social structures, such as harems and bachelor groups, and exposure to climatic extremes, including summer heat exceeding 40 degrees Celsius and harsh winters falling below -30 degrees Celsius. Transitional enclosures also gave conservationists the chance to monitor each horse's health and stress responses before considering full release. The third phase, full reintroduction, began in 2001. That year, the first group of 27 horses was transferred from Jimsar and other facilities into Kalamaili's transitional zone. After months of monitoring, these animals were fully released into the open reserve, which spans 14,000 square kilometers and features sparse vegetation, rolling sand dunes, gravel plains, and intermittent water sources. The reserve's ecosystem is typical of the cold desert steppe, once inhabited by wild Przewalski's horses, prior to their disappearance in the mid-20th century. Subsequent releases followed in a staggered manner, with new groups added in 2004, 2007, and 2011, gradually increasing the population while ensuring the reserve could support the grazing pressure. By 2020, over 120 horses had been reintroduced into the wild at Kalamaili. Field observations and GPS tracking confirmed successful breeding in the wild as early as 2005, with second-generation foals born on site without veterinary assistance or artificial feeding. By 2023, the free-ranging population was estimated to be between 70 and 80 individuals. Ecological studies conducted by the Xinjiang Institute of Ecology and Geography and Beijing Forestry University tracked the herd's adaptation to the environment. Results showed that Przewalski's horses had learned to range across distances of up to 25 kilometers per day in search of forage and water, avoiding steep terrain and establishing seasonal migration routes. They also formed cohesive social units similar to those observed in the Mongolian steppe, harem groups led by dominant stallions and smaller bachelor herds. Though grey wolves occasionally preyed on foals, adult horses exhibited successful defensive behavior, particularly in larger groups. To support the horses during harsh winters, especially during Zard years, park authorities implemented emergency feeding stations stocked with hay and mineral blocks. However, these interventions were used sparingly to avoid long-term dependency. Conservationists also collaborated with local Kazakh herding communities to minimize livestock competition and prevent fencing conflicts. In recent years, efforts have been made to install wildlife corridors and create buffer zones to reduce overlap between domestic grazing routes and the horse habitat. The Kalamaili project is also notable for its scientific infrastructure. Most horses released in the reserve have been fitted with satellite GPS collars, transmitting data on movement, survival, and range utilization. The collected data are integrated into national biodiversity reports and shared with international conservation bodies, including the IUCN's Equid Specialist Group. Veterinary teams conduct annual health assessments using dart tranquilization and blood sampling, monitoring for parasites, disease exposure, and reproductive metrics. Unlike some reintroduction projects elsewhere, China's rewilding program is supported directly by state agencies, including the State Forestry and Grassland Administration, which oversees wildlife conservation policy across the country. This has ensured consistent funding, policy continuity, and integration with broader desertification control programs in Xinjiang. China's three-phase strategy has yielded measurable outcomes. The success rate of post-release survival in the first 3 years ranged from 60 to 75%, with foal survival increasing over time as conditions stabilized. Behavioral surveys indicate a clear shift from dependency on humans to fully autonomous wild behavior by the third generation. China's rewilding approach is one of the rare examples where reintroduction occurred not in forest or alpine regions, but in a harsh desert steppe ecosystem, pushing the limits of what captive-bred ungulates can endure and adapt to. Through it all, the Chinese protected the herd against all threats. Ecological and scientific support. The long-term success of China's Przewalski's horse rewilding project, particularly within the Kalamaili Nature Reserve in northern Xinjiang, could not have been possible without ecological and scientific support. One of the most advanced tools used in the field is GPS satellite telemetry. Starting from the first releases in 2001, Chinese researchers began fitting select individuals with GPS collars capable of transmitting location data at frequent intervals. These devices, typically solar-powered and lightweight, allowed scientists to monitor herd movement patterns, grazing behavior, seasonal migration tendencies, and range fidelity. The Xinjiang Institute of Ecology and Geography, under the Chinese Academy of Sciences, together with staff from the Xinjiang Wild Horse Breeding Center, processed and analyzed this data to determine the ecological footprint of the horses and to adjust management strategies accordingly. By the late 2010s, over 30% of the released population was being tracked in real time using satellite collars. Complementing these efforts are drone surveys, particularly useful in terrain where ground access is difficult or when quick assessments are needed. Drones equipped with thermal imaging and high-resolution cameras have helped document herd size, health status, and foaling events, especially in remote or mountainous zones of the reserve. These unmanned aerial systems are also used for scouting predator activity, primarily grey wolves, and for identifying habitat degradation. To mitigate the natural stresses of the harsh continental desert climate, conservation authorities implemented supplemental feeding programs during critical periods, especially in desert winters, which are characterized by extreme cold and poor forage availability. During these events, mortality among young and older horses can spike dramatically. In the winter of 2009 to 2010, for example, severe snow cover and sub-zero temperatures led to above-average mortality in foals. Since then, rangers at Kalamaili have set up feeding stations with hay, salt licks, and mineral blocks at known foraging routes and seasonal congregation points. Feeding is kept to a minimum to avoid long-term dependency, but it significantly improves winter survival rates, particularly for pregnant mares and juvenile horses. Veterinary care is another critical component. Mobile field teams conduct routine health evaluations using remote tranquilization, blood draws, and physical examinations. Animals are screened for internal parasites, hoof integrity, injuries, and infectious diseases such as equine influenza and strangles. There is a strict quarantine protocol for horses moved between breeding centers and the reserve to prevent disease transmission. Additionally, vaccination schedules and deworming regimens are maintained in line with international standards, guided by recommendations from institutions like the European Endangered Species Programme, or EEP, and the International Union for Conservation of Nature, or IUCN. Predator pressure, particularly from wolves, is addressed through a combination of non-lethal deterrence and habitat manipulation. Fences are avoided in most of the reserve to maintain ecological integrity, but buffer zones have been established around key foaling areas. In 2012, the Kalamaili Reserve began a wolf monitoring program using camera traps and GPS-tagged individuals to track predator behavior and understand overlap zones with the horses. Findings from these studies helped refine release site selection, ensuring that the most vulnerable groups, pregnant mares and newborn foals, had access to safer terrain during critical periods. Human-related threats, such as poaching and overgrazing, have also been tackled through community engagement and governance mechanisms. The region is home to Kazakh pastoralist communities, whose livelihoods depend on livestock herding. The conflict between conservation and pastoral use was once a major concern, particularly regarding grazing competition and water access. Since the early 2000s, reserve managers have initiated compensation schemes, pasture rotation agreements, and education campaigns to build local support. The reserve now employs local herders as wildlife monitors, patrol officers, and seasonal staff, creating a sense of shared ownership over the horses' survival. Beyond the horses, environmental restoration at Kalamaili has supported the return of other native species. Projects targeting biodiversity regeneration include reseeding native grasses, protecting riparian zones, and removing invasive plant species. The Przewalski's horse is a keystone species in this landscape. Its grazing influences plant composition, seed dispersal, and even dung beetle activity. In areas with established horse populations, researchers have documented increases in rodent diversity, better ground cover, and improved soil aeration, showing the broader ecological impact of the reintroduction. Populations of other species, such as the goitered gazelle and Mongolian wild ass, have also stabilized, likely benefiting from the restored ecosystem balance. To ensure that conservation remains adaptive and data-driven, the Kalamaili program publishes annual ecological impact reports, many of which are peer-reviewed and used in broader national conservation planning. These reports integrate data from over a dozen disciplines, including wildlife biology, veterinary science, remote sensing, and community sociology. So, what has all of this yielded? Well, more than what anyone could have imagined. Results of the Chinese reintroduction. By 2013, China's reintroduction efforts for the Przewalski's horse had reached a critical milestone. 127 individuals were living freely in the Kalamaili Nature Reserve, located in the northern part of the Xinjiang Uyghur Autonomous Region, while 107 foals had been born in the wild since the first release in 2001. These figures reflected the survival of a species that had been completely extinct in the wild since the 1980s. With survival rates among foals estimated at over 70% in several early cohorts, this initiative demonstrated that Przewalski's horses could not only adapt to the desert steppe environment of Kalamaili, but also breed successfully under semi-natural conditions. By 2018, China's Przewalski's horse population in Xinjiang, including those in semi-wild enclosures at the Xinjiang Wild Horse Breeding Center, and fully released animals in Kalamaili, had surpassed 400 individuals. This included more than 100 animals roaming freely and several hundred managed under low human intervention conditions. The breeding center near Jimsar County, which was originally established in 1985 with 18 imported horses from Europe, had become the foundation of China's modern horse population, representing the consolidation of the global gene pool derived from 12 to 14 founder animals captured in the early 20th century. Genetic diversity, while still limited, has been carefully managed through international stud books and cooperation with institutions such as the Prague Zoo and San Diego Zoo Global. Despite these gains, there remains a technical distinction in conservation status. Under China's own legal and ecological classification system, Przewalski's horse is still considered extinct in the wild within the country. This classification hinges on a strict definition requiring animals to survive and reproduce completely independently of human intervention. While horses in Kalamaili roam free and breed naturally, supplemental feeding in harsh winters, protection from predators, and veterinary surveillance mean the population is not yet fully autonomous. This cautious approach is consistent with IUCN reintroduction guidelines, which emphasize long-term self-sustainability before delisting is considered. Globally, the IUCN Red List currently lists the species as endangered, a significant improvement from its former extinct in the wild status that persisted until 1996. China's contribution has been acknowledged internationally as a critical part of the species' survival. The Kalamaili model, with its staged approach of captive breeding, semi-wild transition zones, and eventual full release, has been cited in multiple international conservation forums as a viable template for reintroducing other extinct in the wild species. The program's scale, systematic monitoring, and integration of ecological science have elevated it as a flagship project in China's broader ecological civilization policy framework, launched under the 13th Five-Year Plan. China's success has had ripple effects across conservation science. Inspired by the growing numbers in Mongolia and China, global conservationists have launched parallel rewilding efforts for other species, including European bison, Asiatic wild asses, and Saiga antelope. Within China itself, lessons from Przewalski's horse program have informed projects for species such as the Tibetan wild ass and snow leopard, where reintroduction is not yet feasible, but habitat restoration and population monitoring have begun. It is indeed a story of survival against all odds. Well, that's it for now. Thanks for watching. Did you like this video? If you did, please consider liking, dropping a comment, and hitting the subscribe button so that you don't miss out on our new uploads. Also, don't miss this video you see on your screen right now. It's truly unbelievable.